Hi, my name is Kelly. I'm at the PNW District Bonney Lake event with Team 2522 Royal Robotics. Between their first and this event, they've made a ton of modifications and have overcome a tough match schedule to come out on rank 2 for playoffs. We're going to be talking about their drivetrain and their choice of source modules, and then their cool double jointed wrist and pivot here. And then kind of the strategy that went into what they decided to focus on between last event and this event. And then they're going to talk about the sensors. All that and more on Behind the Bumpers. So I see you've chosen the Mark IV modules instead of the Mark IV-I modules this year. Why is that?
Last year we chose to use the Mark IV-Is because it was just more convenient at the time. This year we found the Mark IVs were the more obvious choice as it had a lower footprint and allowed us to fit all the contraptions that we wanted within the bot without sacrificing all the space for the source.
Awesome. So moving on to the scoring mechanism, I see you've got this cool double jointed arm and pivot. Could you explain that for us, Nate?
Yeah, so when initially designing the arm, we wanted a flexible scoring mechanism that could score on every single level and also intake from the source. So we decided to design it with a pivot and a wrist. The pivot is a dead axle with a 3D printed pulley directly bolted into the plate. And then the wrist is a double pulley that connects up here to another dead axle on the wrist. This pulley here is mounted on bearings, so it can spin on the same shaft as the pivot pulley while being independently powered.
All right, so let's see a demonstration of that scoring.
This is our source intake position, which allows us to easily get it from the source. It is pretty precise, but it works pretty consistently. We have a level 2 position, which is able to score on the second level of the reef, as well as a level 1 position, which is able to score on the trough. Since our week 1 event, we've added a ground intake position, which can be seen like this. We actually tweaked this position during our event this week to make it more consistent so it can pick up from different angles of coral.
I see you have different diameters of wheels on each side. Why is that?
So the different squishiness of the wheels allows the coral to be intaked from a certain direction every time. Generally, if they're the same diameter, it tends to get squished on either side or stuck on the wheels, but having one wheel more firm allows it to easily intake it straight in.
Awesome. What made you decide to go with a ground intake for your second event?
During our first event, we experienced a lot of defense, which heavily slowed us down, and we saw other teams with ground intakes be able to evade that defense, and they were a lot faster. We also decided that not traveling to the source, if we were able to pick up coral from the ground anywhere around the reef, it'd be a lot faster for our cycles, and has proved to be very successful.
Awesome. Well, moving on to the other mechanism behind the robot, we'll go on with Allison, who's going to explain what this was for.
So this mechanism here was initially a ground intake for coral. We prototyped it for about 2 weeks, had about 4 different iterations, and upon building, our robot was overweight, and we had to go through and figure out which was actually the most important. We ended up prioritizing our climber over the ground intake because we figured it would score more points in the long run, and cut most of our bottom rollers off of this, but kept our upper green compliant wheels. After we had those during our week 1 event, and they had the capability to process algae, but we didn't use it during our week 1 event and ended up taking them off for additional weight since then. Now it is only there to act as the counterbalance for the elevator, a job that it does pretty well.
So why did you decide to move on with other parts of your scoring for your week 3 event?
We decided to move away from this because of how much weight it ended up adding. Taking off the majority of this piece cut us about 15 pounds, which we weren't able to easily cut otherwise without sacrificing like part of the elevator or other crucial components. Eventually, we figured out that we could more easily add small compliance wheels to our arm, as seen earlier, which made ground intake a lot faster and easier. Though maybe not as versatile as this, it made it a lot easier and was a lot more weight lenient than fixing this would have been.
Awesome. Well, we'll move on with Nate, who's going to talk about the different sensors on the robot.
Yeah, so we have 2 cameras on the robot on the left and the right side of the elevator. We use these cameras during auto and teleop for auto align. It's proved very successful. Our auto is very consistent. At the start of every match, we get our location on the field from the cameras reading the airfield tags. We use full field pose, and then we use pit tuning positioning on the field to travel to our spots in auto and place it. During teleop for our auto line, we use the same cameras and the same system with a group of set points that we go to for each reef position with a left and a right button, and it goes to the closest face. Our last sensor here is on the ground intake. It's this beam brake here. When we intake coral, we have LEDs on the side, and the LEDs turn a different color, they turn purple. So that lets us know when we have a piece of coral successfully intook. When we're turned around and we can't really see the intake because it's on the other side of the robot, it's a lot easier to see the LEDs, and it lets us be much faster and more consistent.
Awesome. Well, thank you for explaining your robot. Good luck in playoffs. This has been Royal Robotics on Behind the Bumpers.